Welcome back. Let us discuss one more problem from ray optics, refraction of light through a glass prism. Important for your JEE main and or your medical entrance examination. Now, if you look at the diagram is drawn for minimum deviation, that is QR. The ray within the prism is parallel to the base of the prism. So in that case, this R1 will be always equal to R2, and this I on this side and this E on this side will also be equal. That is for minimum deviation. What is given? A prism of refractive index mu. The refractive index of this glass prism is mu. And the angle of the prism is given as A. It is placed in minimum deviation position. That is, the ray within the prism is parallel to the base of the prism. It is, if the angle of minimum deviation is equal to, if the angle of minimum deviation is equal to angle A, then the value of A is 2 cos inverse mu over 2. That we have to prove. Now look at. Now, since it is placed in the minimum deviation position, this refracted ray QR is parallel to the base BC. And we always know for a prism, this angle A is always equal to R1 plus R2. This PQ is the incident ray, was supposed to travel in this direction. It has bent by this much, called delta 1. Here it was supposed to travel in this direction. It has bent by this much, called delta 2. And delta 1 plus delta 2 is the total deviation, and we know A plus delta is always equal to I plus E. And this angle A is always equal to R1 plus R2. This is always true. And during minimum deviation, this R1 is equal to R2 and this I is equal to this E that we have learnt in our theory classes. So, using the expression A plus delta is I plus E, where delta is the total deviation, that is the sum of delta 1 plus delta 2. So, if you apply this for minimum deviation, and I represent minimum deviation as a delta M, then for delta I write delta M, minimum deviation, and during minimum deviation these two are equal. So, for E I can write I, so I plus I, that is 2I. So your I is equal to 2 comes to this side, A plus delta M over 2. And during minimum deviation, this angle of refraction R1 here and this angle of incidence within the medium R2, both are equal. And since A is always equal to R1 plus R2 and both are equal during minimum deviation, so for this I write R, for this also I write R plus R2 R. So your R is equal to A over 2. Now, so apply mu. So if you apply, either you apply it here or here, the Snell's law, sine I of sine this angle will be mu of this medium by mu of this medium. Since this is equal to 1, so sine I over sine R1 will be mu over 1, that is mu. So mu is equal to sine I over sine R. I just calculated as A plus delta M over 2, R I just calculated as A by 2. Now it is given the minimum deviation is equal to the angle of the prism. So for delta M, I can substitute A. So mu is equal to sine, here I write A plus A over 2, sine A over 2, 2A over 2, that is equal to sine A. Now, here is the trick. This you can rewrite it as sine 2 of A by 2. If you cancel 2 with 2, you are left with the same sine A. I need to cancel this term, sine A by 2. So I am converting this sine A to sine 2 times A by 2. So this comes under the formula sine 2 theta. So your mu is equal to, sine 2 theta, 2 sine theta cos theta over sine A by 2. Theta means A by 2. A by 2, I am taking it as a theta. So sine A by 2 cancels, so we are left with 2 times cosec A by 2 is your mu. Now, so 2 was multiplied here. If it comes to the left hand side, it will be divided. Mu over 2 is cos A by 2. Cos A by 2. So only a few more minutes left to. So So mu by 2 is cos inverse, a by 2 is equal to cos inverse mu by 2. So if you take cos inverse on both sides, so a by 2 will be cos inverse, a by 2 will be cos inverse mu by 2. A by 2 is cos inverse mu by 2, so 2 is denominator, comes to the here in the numerator, so a will be 2 times cos inverse mu by 2, right? So that's a good question. So thank you very much.